and there might be a little bit of friction in there about what's going on in terms of graphing this out. But what I used to do in the stone mill when I did my Master Mason walkthrough is I would floor inspection, air crane, make sure that the air cranes are good. That's the first thing I see in the floor schematics of this building. I'm going to show you a picture of it here so you know what you're looking at. Now this is not the whole building, but this was the main building that I was operating in. That right there is saw 1, saw 2, saw 3, saw 4, saw 5, and I had to operate all these. I had to ground guy that, I had to ground guy that, I had to operate that, I had to sawyer that, and I had to be a master mason, keep track, tallies, and of course other bookworks with this. So you'd start in, here's the air crane, down there. You'd come into the building there, there's an air crane. First thing I'd do when I walked in is I would check that air crane. That was the length. When I know that takes about 5 seconds. Now, that may not seem like much, but if you don't do that 5 seconds, that seems approximental there, then somebody could lose a rock and have it drop because the pads were screwed up, and the calculations of losing a person on the floor like that start to add up in a hurry. Get back here. Now this whole process of my walkthrough usually took me about 10 to 15 minutes depending on which route I took. But that's what it was every single day. I devoted this system before I ever turned on the saws, before I ever started to do things, because without that checklist I could have got wrecked by somebody else's department in there on day shift because I was working third shift. Alright, so air crane, lines first, rollers, rock under line, rollers, and stand, rock under rollers. So that whole operation, air crane, I had to put rolls on there from the saws. You take them off with the skid steer. You put them on the rollers. You push them back, and then the air crane puts them on the tread line, and that cuts the tread line. That was their department. I knew how to do that. I can thermal, I can sawyer, I could do all that. They advanced me into a operator sawyer's position, which then you advance into mechanic parts and doing everything, checking the maintenance cabinet to make sure you got all parts at some point in time, make sure your inventory for gears, motors, sensors, and everything are up to date. That way we're not calling in for extra parts every day. We have extra of them, so all we have to do is grab the sensor, put it in the machine, which is a timed event, and now you know the calculus on that. You can add and subtract the rates in terms of that sigma, that environment now, which isn't just any and all environments, but specifically the way we train it in a set theory, a delta algebra, that you can say that we will recreate this methodology, but right hand rule here is going to say Bell's inequality. Don't be trying this in this stone mill any other fucking way. Start with the graphics on that roller, air crane, sigma, master mason walkthrough for 15 minutes before you do anything. Any other time you do something like that, that is what you're recreating. And usually it comes up as a time fraud, work fraud case for harassment or something like that, because then you're adding more friction or heat to the situation that was probably not there. This is where things divert, because you have to come in that building that way, and you have to go to the floor where there might be a divergent of systems. If I was running the tread line check, because it would have been an alternate bi-daily system, first we do the tread stacks. I'm going to check all the rock inside of there. Burner's line, torch, rip line saw, chop line saw, burner number 2, the grade line, floor, the yard floor, and pallet inspection. So all on that tread line, you have to say, first I'm going to have to check the stock material that they're using on the rollers. And you're going to make sure they're all at the right thickness. You make sure that nothing's on there. If it is, mark it. Tell them to run it accordingly down the line. Write it on a rock like that. That is your environment. Those are the numbers that you'll be dealing with, because there's no way to really guarantee any of that's going to happen. So we have to check. We have to put an observation of the photoelectric effect on this field, because otherwise you get a big old shock. Whatever form of action, the spooky distance that may come into. Then you have the burner's line. That's the rollers. Are all the rollers smooth? Are none of them geared up? There's no rock locked inside of that system. The torch in itself, light the torch. Make sure that the gas pressures are good. There's no leaks in those lines or anything like that. This is a mechanical sentinel operation, Tomb of the Unknown Mason situation. That takes 2 seconds every single day. Grab your striker, hit the torch, make sure the pressure gauges are on, make sure the torches are on, because otherwise you'll have some kid running around having no clue as what to do and you'll lose your ass in that mill. Rip line saw, is the saw on? Did you turn it on for operations of that day? If it was already on, does it look like it's good? Is the cuts on the inverse of the cuts that they're doing? Check the stack of stone, which we'll get to here, is the rip saw, chop saw, which are together, burn line 2, and the grade line, right? So if the burn is good, the ends are cut good, and the rips are all square, then you know that the inversion of that, the inverse pilot theory on the system is correct. Because if I can fly it, then somebody else can fly it. Not a direct inverse. We're still people, but the difference is it's not me, and it's somebody else. So you got to watch this stuff in math, guys. You really pay attention to it. All right, if that was not the daily operation we were doing inside here, then we're going to say, instead of the tread line stacking and taping everything, we're going to run to the tool shed. Make sure that they have a proper inventory in there. It's not a mess in that tool shed. Some day crew or night crew didn't have the proper orientation inside of there. And I know what somebody's going to say, well, how do I have time for this? You have time for this. I promise you, if I see you in the overhead on that camera, if I knew the inverse pilot theory or dark matter down there on that floor by calculations at inverted square law, chips on that roller's lines, doing things as far as an operator, I'll be all over you, because I had to figure this out to make sure that those things didn't have a problem in there. So if I seen you fucking around, I'll be all over you. Tool shed, bay inspection, saw inspection, billet inspection, cut dynos, maintenance logs, mud stacks, overall no cutting corners, and of course bottom limits and things like that on the saw and outer edge. Make sure that the saws aren't run at full cut if there's only 5 footers or 3 footers in there. Make sure the brakes are correct. Make sure the bottom limits and top limits on the saw are right, because otherwise you'll blow off every single tooth on that saw, or potentially not cut through that rock. When rocks don't have cuts on them like that, they beat up the rollers. That changes the maintenance log, and you want to make sure all this stuff is mechanically as sound as possible. So I'm a little bit running out of time, but you'll run these routes. Run those routes. Make sure you run one that's calculable. Things worked, 1. Things didn't work, 0. I tried this run. It was a positive effect. I had less problems. And I did other routes where I had more problems. Trying to do the maintenance log, or how many parts there is in that maintenance cabinet, might be too much. You have to change this environment. And that's a delta. Change. Make sure that you can live in this box. This stuff is possible. It's just in that range of not being this. Don't listen to this fucking fluffery if you don't know what it is. Make sure they give you something. And do not ever excuse them for doing something like this, not helping you as a student, especially when they're getting paid to do so. Catch you on the next one.